Did you know how a rocket works and how it flies? Okay, if you don't know, let's find out. Picture a machine that defies gravity, breaking away from the Earth's grip, and venturing into the limitless expanse of space. This engineering marvel, which we call a rocket, has turned the long-held dream of traversing the cosmos into a tangible reality. Rockets are more than just tubes brimming with high-powered fuel. They are complex systems of components, each having a pivotal role in the journey to space. The heart of any rocket consists of three essential components: propulsion, guidance, and structure. The propulsion system, most often being rocket engines, produces thrust to elevate the rocket into space. Meanwhile, the guidance system ensures the rocket remains on its predetermined path, and the structure, including the rocket body, engines, fins, and payload, keeps everything intact and safeguards the precious cargo. These components constitute the skeleton of any rocket, and understanding them is instrumental in comprehending how these extraordinary machines operate. Their importance transcends our fascination with space. They are vital instruments in our pursuit to decipher the mysteries of the universe. Please like, share, and subscribe. Also, don't forget to comment on this video. Stay with us for the next video. A rocket is a complex machine built from numerous parts all working together. The heart of the rocket, its body, houses the engines, the payload, and many other critical components. The engines, often using a combination of fuel and oxidizer, generate the thrust necessary to propel the rocket skyward. Now, imagine the rocket as an arrow. Just as the feathers at the end of an arrow stabilize its flight, the fins at the base of the rocket serve a similar purpose, ensuring a stable and controlled flight. Then we have the payload, the reason why rockets exist in the first place. This could be anything from a satellite, a scientific instrument, or even astronauts destined for the International Space Station. Each of these parts plays a crucial role in the rocket's journey from Earth to space. Understanding these parts and their functions is the first step to understanding the marvel of rockets. The heart of any rocket is its propulsion system. Imagine the propulsion system as the rocket's heart, pumping the vital energy that propels these remarkable machines into the cosmos. The rocket engines, integral parts of this system, are responsible for generating thrust, the force that propels the rocket skyward. But how does this happen? Let's delve into the fascinating world of rocket propulsion. The basic principle of rocket propulsion is a practical demonstration of Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. In the context of a rocket, the action is the expulsion of high-speed gases from the engine, while the reaction is the forward motion of the rocket. This action-reaction process is what propels a rocket into space. Rocket engines, often referred to as thrusters, work by expelling propellant, a special type of fuel, in one direction, and as a result, the rocket moves in the opposite direction. The engine burns the propellant, creating hot gases. These gases are then expelled out of the engine's nozzle at high speed. The expulsion of these gases creates a force, or thrust, pushing the rocket upwards and forwards. Thrust is generated continuously by the engines, until the rocket reaches the desired speed and altitude. The amount of thrust produced by the engine depends on the amount of propellant burned, and the speed of the gases as they leave the engine. The larger the amount of propellant and the faster the gas expulsion, the greater the thrust. Rocket propulsion is a delicate balance of physics and engineering, a dance of forces that enables us to reach for the stars. It's a testament to the ingenuity of humankind, turning a fundamental law of nature into a tool for exploration and discovery. The propulsion system is the driving force that propels a rocket into space. It's the heart that beats within the metallic body of a rocket, pushing it beyond our world and into the vast expanse of the universe. A rocket's journey is not just about power, but also precision. Now let's talk about a key player in maintaining this precision: the fins. These little wings at the base of a rocket are not there just for show. They play a crucial role in stabilizing the rocket during its flight. Much like the feathers on an arrow, fins help maintain a straight trajectory, assisting the rocket to resist any side winds or disturbances that might knock it off course. Now this brings us to a fundamental principle of flight: aerodynamics. It's the science that studies how air moves around objects. In the case of rockets, their shape is designed to reduce air resistance or drag, allowing them to move through the atmosphere more efficiently. The smoother and thinner the rocket, the less air resistance it faces, allowing it to reach higher speeds with less fuel. The aerodynamics and fins ensure the rocket's trajectory remains steady and true. Guiding a rocket through the atmosphere and into space is no small feat. It's a task that demands precision, accuracy, and an intricate understanding of various scientific principles. At the heart of this challenge is the rocket's guidance system. Think of it like the brain of the rocket. It's responsible for steering the rocket along its intended trajectory, from the moment of launch to the final stage of the mission. The guidance system incorporates navigation and control systems. Navigation systems are like the rocket's internal GPS. They constantly monitor the rocket's position, velocity, and attitude in real time, allowing it to know precisely where it is at all times. Control systems, on the other hand, are the decision makers. They take the information from the navigation systems and make real-time adjustments to the rocket's direction and speed. This could be as simple as adjusting the angle of the rocket's fins, or as complex as altering the thrust of the engines. These two systems work together in harmony, allowing the rocket to stick to its planned path, adjust to unexpected conditions, and reach its intended destination. And it's not just about getting the rocket to space. The guidance system also plays a crucial role in ensuring the rocket returns safely back to Earth, if that's part of the mission. The guidance system is the brain of the rocket, guiding it on its journey into the cosmos. The launch sequence is a ballet of technology and physics. Picture this, a rocket on the launch pad, bristling with potential energy. This is where our journey to the stars begins. The launch sequence is an intricate dance that unfolds in three major stages: ignition, liftoff, and ascent. Ignition is the first stroke of our cosmic ballet. It's when the rocket's engines roar into life, fueled by a complex mixture of propellants. These engines are the heart of the rocket, providing the thrust necessary for the rocket to overcome the Earth's gravitational pull. The moment of ignition is a pivotal one. It's the point of no return. Once the engines are ignited, they can't be switched off. They must either burn out naturally or be destroyed. Next, we have liftoff. This is where the rocket's thrust, now at full power, overcomes the weight of the rocket, and it begins to ascend. It's a thrilling moment, the culmination of countless hours of work and preparation. The ground shakes, the air shudders, and the rocket begins its ascent, climbing higher and higher into the sky. The ascent is the final stage of the launch sequence. This is when the rocket is in flight, climbing towards space. During this stage, the rocket's speed and altitude increase, while its fuel decreases. The ascent stage is further divided into smaller stages, each with its own engine and fuel supply. When one stage runs out of fuel, it's jettisoned, and the next stage ignites, pushing the rocket even higher. This process of staging is key in helping the rocket overcome Earth's gravity and reach orbit. Throughout the launch sequence, the rocket's guidance system plays an essential role. This onboard computer system ensures the rocket maintains its course, corrects any deviations, and ensures a successful mission. The launch sequence is a carefully orchestrated series of events designed to propel the rocket into space. It's a testament to human ingenuity, a perfect blend of technology and physics that allows us to reach for the stars. This ballet of technology and physics is our gateway to the cosmos, our path to exploring the final frontier. What goes up must come down. And so too must our rockets. The journey back to Earth begins with a process called deorbit burn. The rocket's engines fire in the opposite direction of travel, slowing it down enough to fall back towards Earth. Once the rocket re-enters the Earth's atmosphere, it's met with extreme heat due to the friction between the rocket and air molecules. To survive this, rockets are equipped with heat shields that can withstand and dissipate the immense heat. Now, onto the final leg of the journey, recovery. There are a couple of ways this can be done. Some rockets deploy parachutes, slowing their descent to a speed safe for landing. Others, like SpaceX's Falcon 9, perform controlled landings using their engines. They reignite their engines to slow their fall, allowing them to touch down gently on a landing pad. Re-entry and recovery ensure the valuable payloads carried by the rocket are returned safely to Earth. Rockets are more than just machines, they are a testament to human ingenuity and ambition. From their intricate parts like the body, engines, and fins, to the complex propulsion and guidance systems that drive them, rockets embody our quest for knowledge. They're the vehicles that propel us into the unknown, harnessing the principles of physics to defy gravity. They navigate the harsh conditions of space, guided by sophisticated systems that ensure they follow their intended paths. Rockets have revolutionized our understanding of the universe, opening up the cosmos for exploration and discovery.